you got 52 cards and 13 of the cards are facing down, shuffled randomly, and you got to make 2 decks so that each deck has equal number of face down cards, and you're blindfolded. You got to assume that you cannot see the cards. Now let me first of all explain what does face down or face up means. I have few cards here, and these are the cards that actually face up, and these are the cards that actually face down. If you flip these cards, all of them are facing up, and if you flip all of these like this, then they're all facing down. So you can use these kind of tactics or whatever you want to do, but you gotta actually make 2 decks that actually have equal number of face down cards. So you can pause the video and try to solve this problem. When you're done, you can come back to see the solution. Okay, I assume you had a take at it. So first of all, let me tell you the solution straight away, and then I will explain how to actually come to the solution using calculations or mathematics or whatever the approach you want to take. So what you need to do is you need to take a deck of cards. So assume this is a deck of cards that are 52, right? You need to take the top 13 cards, and put them on this side, and you can call that deck 2. So now you don't have 52 cards here, you have 2 decks, and these are 39 cards and these are 13 cards. What you need to do is you need to flip these 13 cards like this. So when you flip these cards in deck 2 like this, you end up having equal number of face down cards in both of these decks, no matter howsoever the face down cards were shuffled in deck 1. Whenever you take the top 13 cards and flip them like this, you end up having equal number of face down cards on both decks. So first of all, let's try to solve this intuitively. I mean, if you assume that none of the face down cards were in top 13 and you take them, that means that all were facing up, right? And when you just flip them, they all are facing down. That means 13 cards are facing down now, and 13 cards are in this deck that are facing down, so they are equal. What if all 13 cards that were in the top of the deck 1 were facing down, right? All the 13 cards were randomly shuffled, but they end up being on the top of this deck. Now you take them and then you flip them, then you end up having none of the cards on each side that are facing down, because these 13 were facing down. When you flip them, now you're facing up, and none of the cards here are facing down. So once again, you're having equal number of cards facing up and down. Okay, what if only 3 of the cards in deck 1 were facing down? Then what? Then you take the top 13. Now you got only 3 of the cards facing down here. When you flip them, you're actually having 10 of the cards facing down now, because there were 10 facing up before. When you flip them, now 10 facing down. And in this deck, only 3 of the cards on the top were facing down. That means 10 of them were facing down in the rest of the deck, the 39 cards, 10 of them facing down. And when you flip these cards, this whole deck, and then you're having 10 facing down here, and the 10 of the cards are facing down here. I hope it made sense, because you just need to have a strong imagination in order to do that. But let me actually solve this mathematically for you, the guys who are interested in mathematics of this or calculations or something like that. You gotta make a column. You gotta write deck 1 here and deck 2 here, and you gotta make some rows. And first of all, I'm gonna write total, face up, face down, and just write down the data for the status of the cards. So the total cards in deck 1 is 39. In deck 2 they are 13. The face up cards in deck 1, I'm gonna just leave that for a while and just talk about the face down cards in deck 1. Let's suppose they are X. The total number of face down cards in deck 2 has got to be 13 minus X, because they were total 13 and X of them are in deck 1, so 13 minus X are going to be in deck 2. So what about the face up cards? In deck 1, the total number of cards is 39 and face down are X. So face up have got to be 39 minus X, right? And in deck 2, the total number of cards is 13 and face down cards is 13 minus X. So face up cards have got to be X, because total face down and face up cards should make up the total number of cards in that deck. You can verify that X plus 13 minus x is equal to 13, and 39 minus x plus x is equal to 39. So you can see that the total number of face down cards in deck 1 is equal to the total number of face down cards, face up cards in deck 2, right? So how to actually convert the face up cards into face down cards? By just flipping them. That's what we did here. We just flipped the cards. So when you flip them, you're going to have 13 minus x face up cards and x face down cards, and that's how you end up having equal number of face down cards in both of the decks. I hope it was interesting to find out the solution mathematically and intuitively both, and I encourage you, I appreciate you if you solve this on your own. Thank you.